Good morning. We're going to take notes number 1 today on solving a quadratic equation. So I discussed in some of the welcome videos just kind of how Algebra 2 runs. And what happens is we kind of start with these small building blocks, and then we continue to build on them as we go through Algebra 2. So although we took a quiz on factoring last week, that doesn't mean that factoring is gone. It actually means that I'm trying to see if we need to keep working on that topic or if we're ready to move forward. And based on the data that we saw in the quiz, we're ready to move forward. And if you are struggling with that concept, we really need you to reach out to us and let us know that you need some extra practice or some extra sessions in order to better understand the topic. But we're going to use factoring throughout Algebra 2, like even in the spring semester, we will still be factoring. So it's important that you get a good understanding and a solid foundation of that in Algebra 2, because a lot of the concepts that we learn later will use factoring as part of the problem. So that's what we're going to be doing today. We're going to be using the factoring that you took a quiz on Friday, and we're going to take it an extra step and solve today using that. So our I can is a little bit different. I can solve a quadratic equation. So this will be notes number 1. And today's lesson is solve by factoring. And I'll put the kind of X as a symbol just to remind you of what we do when we factor. Okay, so solve in the directions or in the notes, it says you want to solve. So we're trying to see or get to what X is equal to. So we will be taking everything one step further today in the lesson to get X by itself to see what X is equal to. So example number 1. And since we are still factoring, I'm going to continue teaching that concept within the lesson today to remind you what the expectation is for factoring. So if you are struggling with factoring, don't feel like you can't listen to this lesson. I will continue to remind you what the important steps are, so you still could pick that up in this lesson. So don't get frustrated and don't give up. You can learn this, and if you need more help, please let me know in the live sessions or send me an email and we'll set up a time for us to work together on Wednesday in a small group session. So as of right now, the problem sort of looks the same as what you were doing in your quiz on Friday. It's x squared minus 10x plus 16. You're going to factor the trinomial. The only thing that we have added to the problem is this equals 0. And that is just a visual representation, or they're communicating to you that you want to set the problem equal to 0 at the end in order to solve. So this is just a reminder that you're going to take this problem all the way to the end and solve for x. But we're going to take the original steps that we took when we started factoring. So I'm going to look for two numbers that multiply together to make 16. And when I combine those numbers together, they're going to give me a negative 10. So in order to get a positive 16 here, we're going to have the same sign, but this negative 10 tells me that they're both negative. So I'll use negative 2 and negative 8. Negative 2 times negative 8 is positive 16. Negative 2 plus negative 8 is negative 10. Because there is not a number in front of x squared, we can go ahead and put it into the factored form. So I can set up x minus 2 and x minus 8. But we're going to bring that equals 0 down, because what we did is we took this problem when we factored it, but it is still the same problem. It is still set equal to 0, and it is a reminder that we're going to need to take this one more step. So what we do, because of that equals 0, because we want to solve, you want to set each parenthesis equal to 0 and solve for x, or get x by itself. So I'll take x minus 2 and set equal to 0, and I'll also take x minus 8 and set it equal to 0. So in order to solve for x, you are going to want to undo the numbers next to x. So this says x minus 2, so in order to undo it, I'm going to add 2 to the other side so that I get x equals a positive 2. So that's one of my answers. Here, this is x minus 8, so I will undo that by adding 8 to the other side. X equals a positive 8. So these are our answers. X equals 2 and x equals 8. So we'll do that one more time, and then I'll let you try one. Number 2, x squared plus x minus 72 equals 0. So the equals 0 is just a reminder that you are going to set the factors equal to 0 and solve at the end, or after you have factored. So we'll set up our x. We're going to look for factors of a negative 72 that combine or add to. We would use a 1 because there is an x in that scenario. When there's not a middle term, that's when we used 0, just as a reminder. But I'm going to use a 1 here because there is an x. Because it's a negative 72, that tells me that I'm going to have a negative times a positive in order to have a negative answer. We'll use 9 and 8. And 9, a positive 9 minus 8 is how we would get the 1 in the middle. So I'm ready to put it in factored form because it is not, there's no number in front of x squared besides a 1. So x plus 9 x minus 8. And the problem is still set equal to 0. So you just want to bring that down with your problem as a reminder that you want to take this problem one more step. So I'll set each of these parentheses equal to 0 in order to solve. Sorry, let me see if I can move this over here. All right, so in order to solve for x, we're going to have to move this 9. So it says x plus 9. In order to move it across the equal sign, we will subtract 9 from both sides. So x equals a negative 9. And then here, x minus 8, we will add 8 to the other side to get x equals a positive 8. So I get two answers, x equals negative 9 and x equals 8. So the next problem I would like you to try on your own. Based on the examples that we have done, try this. So this will be x squared plus 5x minus 36 equals 0. So please pause your video for a second, try this, and then check your answers with me in just a minute. Did you get negative 9 and 4? I hope you did. All right, so we're also going to have to talk about factoring to solve a quadratic when a is not 1 or when a is greater than 1. So we'll do 2 examples of that as well. Now I know that's very math intensive, it is very involved, but it is something that we expect Algebra 2 students to do. So I'll show you a couple of examples and I will have you practice it a couple of times but I won't try to make you do a bunch of those because it is sort of a labor-intensive process, but it is something that we expect you to understand. So let's take a look at that. We're going to solve quadratics. When a is greater than 1, you have factored problems that look like this before. This is where we have to rewrite the middle part and find the common factor on both sides and group the match and the GCFs in order to get our final factored form. We'll just take those one extra step and set them equal to 0 and solve at the end. So let's look at number 1. 5x squared plus 13x plus 6. Again, the only thing we're introducing from what you already should understand about factoring is this equals 0, and it just tells us that we're going to solve at the end. So the process for factoring when a is greater than 1, we're going to multiply 5 times 6. So we need factors of 30 that add to 13. And it's important that you look at this. We are only adding in this problem, so the factors will both have to be positive in order for this puzzle to work. So factors that multiply to 30 and add to 13, we're going to use positive 10 and positive 3. That is the only set of numbers that will work for this puzzle. Sometimes students will try to use 15 and 2 for this puzzle because 15 take away 2, that does make 13, but 15 times negative 2 would mean we had a negative 30 in our problem, and that is not the scenario. So you have to use positive 10 and positive 3 for this rewriting. Again, in this process, we keep the first piece and we keep the last piece the same, and we rewrite 13x using the factors that we found. So I'm going to use 10x plus 3x to rewrite the middle. So I'll put the 10 next to the 5 because they have numbers in common. I'm going to split it down the middle. 5 and 10 can be divided by 5. They can also be divided by an x. You always have an x in common on this first side. And once I divide that out, I would be left with an x plus 10 divided by 5 is 2. On this side, I can divide each of these by 3. And when I divide that out, I get x plus 2. Remember in this process that those parentheses have to match exactly in order for this answer to be correct. So make sure you're still looking for that and keeping that in mind. So we're going to gather up one of the matches. And then we're also going to take the GCFs. So 5x plus 3. This problem is still set equal to 0. So I'm going to make sure I put that on the factored form just as a reminder to myself that I need to take this one extra step. So we're going to set each parenthesis equal to 0 in order to solve. So on this first problem, we'll subtract 2 from both sides in order to get x by itself. Good. So x equals a negative 2. Here on this next problem, we actually have to take 2 steps because there's 2 different numbers that I need to move. First, we'll subtract the 3 from both sides. So I have 5x equals negative 3. And then I will need to divide the 5 over to the other side, leaving me with x equals, and we'll just leave that as a fraction, negative 3 over 5. I don't want you to turn it into a decimal because I'm not sure how Delta Math is going to want you to put the decimal in, especially if it's a repeating decimal. So we'll just leave it as a fraction, please. So you get 2 answers here, x equals negative 2 and x equals negative 3 over 5. So I'm going to show you one more example of that. Here we go. So 2x squared plus 5x plus 2 equals 0. So first we factor. I'll multiply 2 times 2. We'll need factors of 4 that combine to 5. I will need to use everything as positive here, so I'm going to use a positive 1 times a positive 4. We keep 2x squared and we keep plus 2, and we rewrite 5x to be 1x plus 4x. But I'm actually going to put the 4 next to the 2. And split it down the middle. And we'll divide out a common factor. 2 and 4 can be divided by 2. They'll also have an x in common. So I get 2x, x plus 2, because 4 divided by 2 is 2. Here, it doesn't appear that I can divide anything out from 1 and 2, but you always have to have some kind of common factor. So what I'll have to use in this case is I can divide everything by 1. You always have to have a number next to that plus sign. So I'm dividing everything by 1. It's not changing the numbers. So I still have 1x plus 2. That's how the parentheses match. So I've got x plus 2 and 2x plus 1. This problem is still set equal to 0. So that is a reminder that I need to set each of those parentheses equal to 0 in order to solve. So x plus 2 gets set equal to 0, and 2x plus 1 will get set equal to 0. In this first problem, I'll subtract 2 from each side. X equals a negative 2. And on this side, the first step is to subtract 1 from each side. 2x equals a negative 1. And then I'll have to divide each side by 2. And I'll just keep that answer as a fraction. X equals negative. Sorry, I'm going to move this down a little bit. X equals -1/2. Okay, so that's notes number 1 for us. We're talking about solving quadratics by factoring. The other 2 topics that we'll discuss will be solving quadratics using the quadratic formula and solving quadratics using the square root method. I believe you have seen these topics before in Algebra 1, so they should feel sort of familiar, but we're going over it again because we will continue to use these concepts in Algebra 2, and it's important that you feel confident moving forward. Thank you for your time today. We'll practice this concept in Delta Math tomorrow. Thanks, guys.